Hi Pre-Calc, this is Miss Jensen, and we are continuing on with radians. So in the first part of 6.1, we talked about what a radian was, how to convert radians to degrees and vice versa, and how to find the reference angle in radians. What we're going to do today is we're going to evaluate trig functions using radians. So before you were given cosine of 150 and you would draw the triangle, label the sides, and find the ratio. Well, today you're going to be given it in radians. So it'd be like the cosine of 5 pi over 6. Okay, so this is just a review of the unit circle. Feel free to skip this if you more or less understand it, because this is largely we went over at the first half of the last video. But just to remind you, if we're dividing this in radians, this is 0, halfway across the 0 is pi radians, one full circle is 2 pi radians. If we divide the top half of the circle into halves, we get 1/2. Bottom is 1.5, so 3 over 2. If I want to divide into chunks of 30, normally this is 180 over here. Chunks of 30 would be 6. So if I divide that top half of the circle into 6, and remember the top half is just pi, this is 1/6 pi, 2/6, 3 over 6, 4 over 6, so I'm reducing as I go, 5 over 6, 6 over 6, 7 over 6, 8 over 6, 9 over 6, 10 over 6, 11 over 6, and 12 over 6. Okay? If we divided it into 60-degree chunks, that would be dividing the top into thirds. Well, so we start at 0, then we go 1/3, 2/3, 3/3, 4/3, 5/3, back to 6/3 or 2. And finally, if we do chunks of 45, so that would be dividing into 4s. 1/4 pi, 2/4 pi, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. Okay, so that is the unit circle in radians, where those things come from when you look at a copy of the unit circle. Just a reminder, and you can refer to this if you can't remember SOHCAHTOA or the reciprocals that go with it, and how special triangles are related. Okay, so this is just general special triangles, no matter what the shortest side is. If we refer to kind of a unit circle, because the unit circle has a radius of 1. So in both cases, if I say we have a radius of 1, which in this case is the hypotenuse, just again, kind of going back here, to get from the hypotenuse to the short side, you can see I would divide by 2. I would divide by 2. That's on a 30, 60, 90. To get from the short, or the hypotenuse to the middle side, I would divide by square root of 3. Okay? So if I go here, if I'm doing my short side, to get from the hypotenuse to the short side, I would divide by 2. And then, let me just say that again. I would take the short side, which is this, and I'd multiply by square root of 3 to get this. Okay? So we go from whatever the short side is to here. I said that wrong the first time. So the short side to the middle, we multiply by square root of 3. So if my short side is 1/2, my middle side is square root of 3 over 2. With a 45/45, I would divide by square root of 2. So 1 over square root of 2, 1 over square root of 2. Now if I simplified that, multiply the top by square root of 2, and the bottom by square root of 2, this would be equivalent to that. When you look at the unit circle, this is kind of what you see, assuming that the radius is 1, these are where those values come from. But when we draw our triangles, just so we don't have so many fractions, we do 1, 1, square root of 2. Across from the short side is 1, across from the hypotenuse is 2, short to hypotenuse is square root of 3. So, you know, whatever the short side is, it shouldn't really matter. To get to the hypotenuse, you multiply by 2. To get to the middle, you multiply by square root of 3. Here with the legs, no matter what the legs are, they're the same. And to get to the hypotenuse, you multiply by square root of 2. So this is the one I usually like to use just because it's a little simpler. Okay, again, a lot of this is review because we're going to be putting things we know together. In a way, there's nothing new today. It's just putting what we know now all together. So when the terminal side is not on the x-axis or y-axis, that means we have to draw triangles. So we start by finding the location of the terminal side, figuring out what the reference angle is and drawing the triangle, labeling the sides, and then finding the ratio. Okay, so 7 pi over 4. So I'm going to try just to do this in radians. Again, if this is if you're really, really struggling with doing it in radians, you can convert this to degrees, do it like we did before, take your answer and convert it back to radians. But we're going to try to stick to thinking in radians. So remember, this is 0, this is 1 pi, this is pi over 2, this is 3 pi over 2, and this is, if we're going into fours, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. This is where 7/4 pi is. It's right here. Okay. And then I'm going to draw a line up to the x-axis. This is also 2 pi. And I want to figure out how big this angle is. How far is it from 7/4 to 2 pi? Now remember, 2 pi is the same as 8 over 4. So how far is it from 8/4 to 7/4? It's 1/4. That angle there is pi over 4. Now that's the same as 45 degrees. So, you know, but my answer is pi over 4. That's actually the reference angle. Okay, I'm just going to leave that small for now because what I really need to do is find my ratios. So this is the same as a 45/45. Pi over 4 is the same as 45/45. And my label on my sides here is 1, 1, square root of 2. I go to the right one. So if I'm going to the right one, that's positive. If I'm going down one, it's going to be negative. And then my hypotenuse is square root of 2. So from the center, if I'm finding sine, sine is O over H. My O is -1. My H is square root of 2. Or I can multiply the top and bottom by square root of 2, and I get negative square root of 2 over 2. So either one is fine. So I can either say my ratio is -1 over square root of 2 or negative square root of 2 over 2. Let's try another one. 5/3. So let's think in thirds. 0. So if we go 1/3, 2/3, 3/3, 4/3, 5/3, and 6/3. I'm going to write it as 6/3. But this is the angle. I'm going to go straight up. And what I want to find is I want to find this angle here. What is my reference angle? So how far is it from 6/3 to 5/3, which is pi over 3? So that's my reference angle. Again, if I can't stand pi over 3, which, you know, I still kind of like to work in degrees also. Pi over 3 is the same as 60. Your reference angle is always going to be 30, 60, or 45. So that is a 60. And then across from 60 is square root of 3. The hypotenuse is 2. This is 1. Again, I'm going right, so that's positive, but then down is negative square root of 3. So cosine is A over H. My A is 1. My H is 2. All of that for 1 over 2. Let's try a couple more. 13 pi over 4. So first of all, 13 pi over 4 is not between 0 and 2 pi. So I'm going to minus pi over 4. 8 pi over 4. 13 minus 8 is 5. And so this is 0. This is pi. And this is 5 pi. It's not a very nice 5 pi though. 5 pi over 4. Okay? And we'll go up. All right? And so remember, if we're going in force, this is the same as 4 force. So how far is it from 5 force to 4 force? It's 1/4. So this reference angle is 1/4 pi. You know, really 1/4 pi is the same as 45. Because what I want to know is what my sides are worth. This is 1, 1, square root of 2. I'm going left, I'm going down. From the center, this is my opposite, my hypotenuse, and my adjacent. So cotangent, oops, sorry about that. Cotangent is not OA, it is A over O. My adjacent is -1, my opposite -1, and my cotangent is 1. Right? I'm just going to do one more like this. This time, I think I'll just show you if you how you can do it in degrees. So remember how we convert to degrees. We're going to put this over pi. So I want to know how many degrees is equivalent to 5 pi over 6. So the pi's cross off, and I'm left with x over 180 equals 5 over 6. We can cross multiply, and we get 6 times x equals 5 times 180 divided by 6, and we get 150. So again, if I just can't stand doing radians, but try to think in terms of radians, I can switch it to degrees, and then just do it like we were doing in the last unit. This is 150. This is my reference angle. Across from 30 is 1. This is 2. This is negative square root of 3. Okay, and this is the adjacent. Okay, so for cosecant, cosecant is reciprocal of sine. So instead of OH, it's HO. My hypotenuse is 2. My opposite is 1. Yeah, and in this case, I don't have to convert it back to degrees because my answer is a ratio. So for the ones we're doing right now, our answers are ratio. We don't need to convert it back. When we do the inverse, which we're going to do next class, next lesson, then you would have to convert it back to radians because your answer is going to be in degrees. Here you don't. Okay? All right. Now, just to kind of finish up with when the terminal's on the x-axis or y-axis. These are the directions. Find where terminal side of the angle will land. Identify the coordinates of the point on the circle in that location and find the trig function. So find the terminal side where the angle will land. So again, I want this to be between 0 and 2 pi. So I'm going to take 7 pi over 2. I'm going to minus 2 pi. And I get 3 pi over 2. Okay, so this is equivalent to the tan of 3 pi over 2. So this is 0, this is pi over 2, this is pi, this is 3 pi over 2. So this is where we are here. Well, this is on the circle, so it's on the x-axis, y-axis. So identify the coordinates. This is 1, 0, 0, 1. This is -1, 0, 0, -1. And remember that cosine is x, sine is y, and tan is y over x. A lot of times people want to go x over y. It's sin over cos. So my y is -1. My x is 0. And when you have 0 in the denominator, that is undefined. Okay? So I think we will quit there. Nope, never mind. I think that's the only example in the hard copy of the notes as well. So that is it for today. Good luck with the assignments.